projectile motion. Again, this is like kicking a soccer ball. You have a soccer ball sitting on this is the ground here, and you kick the soccer ball and it travels like this. Or if you're a golfer hitting the golf ball, basketball player, the same thing. So you actually have motion in two dimensions. You are moving in this direction. Notice the soccer ball is going in the x direction, and it's also going up and down in the y direction. Or you could be on top of a building and you throwing or something roll off a table there. You have a golf ball or a tennis ball sitting on a table, and suddenly that ball travels like this. That's also motion in two dimensions. Notice the ball traveled in this direction, that's the y direction. It also traveled in the x direction, in that direction. So that's what projectile is, motion in two dimensions. You have things that are moving in two directions, in the x direction and the y direction. The one thing to remember about projectile motion, that the acceleration in the x direction is 0. So the acceleration in the x direction is always a 0. And once the acceleration is 0, there's only one equation that will work for this in the x direction. That means the velocity in the x direction is also constant. If your acceleration is 0, your velocity is constant. So the velocity in this direction here is the same velocity here. It's the same velocity here. It's the same value, the same value, the same value in the x direction. The same thing right here. The velocity in the x direction is the same. And since the velocity is constant, there's only one equation that you can use in the x direction, and that is x equals v0 times t. That's it. All the four equations from the past that we use, where's my four equations? I had a sheet of paper. All these will shrink to one equation. It becomes one equation. Now what about the y direction? Let me see what we have in the y direction. I'll do a different picture. Well, actually, I'll leave this picture. I'll just use the blue for the y direction. Like in this case, if you watch the velocity in the y direction, initially it's going to be a large velocity. That's why the ball is rising. That's in the y direction. Then start to decrease. And when you get to the top, the velocity in the y direction is almost 0. At the peak, the velocity in the y direction is 0. Then once the balls start to come down, you'll notice the velocity in the y direction start to increase. So the blue is the velocity in the y direction. So initially on the top here, the velocity in the y direction was 0 because it's horizontal. But as it leaves that, you'll notice that velocity in the y direction start to get larger and larger. In the y direction for a projectile, the acceleration is what? Is gravity, which equal to negative 9.81 meters per second squared. In the y direction. And all these four equations will be there. Since the acceleration is not 0, you can use any of these four equations, any one of them. The only thing when we start talking about y direction, we might change the name of these. Instead of x, remember we use y. So this equation will be y equals y sub 0 plus the v average in the y direction times time. I'm using subscript for y. What's the velocity in the y direction? V equals v0 in the y direction plus the acceleration, which is negative 9.8, that's the acceleration, times t. Or I can write g times t, because a equals to g here. The third equation will say y equals y sub 0 plus v0 in the y direction times t plus 1/2 the acceleration, which is g times t squared. And the last one, v squared equals v0 squared plus 2g times y minus y sub 0. The only thing I don't like about what I wrote there, maybe I should just put g in place of negative 9.8. Since I use g in every one of them, might as well put g here. I mean, you can use either one. So these equations, we just change x to y, and we change the acceleration to gravity. Which one?
For the VOY.
Yes, that's just the initial velocity in the y direction. That's one thing.
Is that whole thing squared?
Yeah, that's just one thing. It says the initial velocity in the y direction, so it's one number. That's just a subscript.
I have accident squared the y, not the initial
Oh.
on my thing, so I was like, ooh, fix that.
So I'll give you an example, a couple of examples here just to show you how projectile works. I always tell people, when you see an accident, a lot of times you see the state police there measuring. You say, what could they be measuring? You know? What can they figure out from these numbers? And I always tell people, it's simple. If a car goes off a cliff, tell me how high the cliff and where the car landed, I can tell you how fast the car was going. What was the initial speed? We know if you were speeding or not. So we won't use a car, we're not going to kill anyone. Well, I'm going to roll my tennis ball now off the table, and based on my speed, it's going to land somewhere. The height of the table doesn't change. Notice, I'm not going to lift the table up. If I give it initial speed, there we go, it drops about 2 feet from me. If I give it larger speed, it drops 4 feet. Give it a good speed, like a bullet there, will go about half a mile. So how do we figure where it's going to land? So let's take an example. We have a table that's horizontal. There's my table. There's a tennis ball, actually. I'm going to push that tennis ball with initial velocity to the right. And let's choose a number. How fast you want it to go? Pick a number. How many meters per second?
90.
90? 20 meters per second. That's still about 50 miles an hour, so that's still a fast one. That table is roughly 1 meter high. The ball is going to go like this because it's really moving fast speed. It's going to take a while for it to hit the ground. So let's ask for a few questions. Find the distance x, where it's going to land. That's the first question. Second question, find the time it took to reach the ground. Bless you.
Thank you.
How long was it in the air? And question number 3, find the velocity before it touches the ground. Right before it touches the ground, reaches the ground, how fast was it moving? These are the 3 questions.
U, A, and E before.
So I'm asking for a lot of stuff here. What I'm going to do with every problem in projectile is break it down to 2 stories. I'm going to look at it in the x direction, and I'm going to look at it in the y direction. What's the initial velocity in the in the x direction? Zero? Somebody said? Valentina says 0. Why 0? If it didn't have initial velocity in the x direction, if it was 0, if this is the table, the ball will go like this, straight down.
We don't know.
It will never go like this.
So we don't know.
Is somebody pushing it?
Yep, somebody pushed it with that speed.
Who was it, 20?
It is 20. That's your initial velocity in the x direction. In the y direction, what's your initial velocity in the y direction?
0.
That's a 0. It wasn't going up or down. What else we know in the x direction? Do we know that distance x? No. Do we know what the time is? How long was the ball in the air? No. Remember, there's only one equation in the x direction. X equals v0 in the x direction times the time. So that's x equals 20 times t. I can't answer that question. Why? How many unknowns in it? 2. Now in the y direction, what else do we know? Let me use blue for y. We know the initial velocity is 0. What else do we know?
Would 1 meter be for the x?
That's the initial height, yes. It's 1. What about the final height when it touches the ground?
0.
We know the final height. Do we know what the acceleration once the ball leaves that table? In the y direction, the acceleration is always what?
Negative 9.
Gravity. So you know the acceleration. That's what we know in the y direction. And remember, I said in the y direction you have access to all these 4 equations. It looks like it if I use equation number 3, I know this, I know this, I know this, I know this. How many unknowns in it? Only the time. So I can answer question number 2. If I know the time, can I find x?
Yes.
I can answer question number 1. So what I'm going to do here is use equation number 3 to solve for the time. I'm going to replace x with y equals y sub 0 plus the initial velocity in the y direction times t plus 1/2 gt squared. y is 0. What's y sub 0? 1. The initial velocity in the y direction 0 times t. This will be plus 1/2 times negative 9.8 t squared. About 0.62, I think. Let me take the square root. Notice I'll move this minus to this side. 4.9 t squared equals 1. T squared equals what? 1 over 4.9. .204. What is t? The square root of that number, right? 0.45 second. So that ball is in the air for roughly 0.45 seconds. That's question 2. We just answered that. If I have the answer to question 2, can I answer question 1?
Yes. Just substitute t for
X equals what? 20 times t.
4, 5.
20 times 0.45. It's 9 roughly. 9.04 meters. That's the answer to question 1.
I got 20 times 0.45 is just 9.
I just carry all the numbers on mine. So when I write that number, I'm really using all the time. Like if you look at mine,
Yeah.
I might write 0.45. I'm using all these digits.
Oh.
Now question 3, it says, what is the final velocity? Well, let's look at this. Can I find what v final is? Let's look at the equation. Do I know what the initial velocity in the y direction is?
Yes.
Do I know what the acceleration?
Yes.
Do I know what the time is?
Yes.
So I should be able to find what the velocity in the y direction. I'm leaving that picture there. Oh, I don't know why I said G, 2G. It's A times T. Yeah, I'm thinking of the other equation. I mixed two equations. V equals V0 plus GT. Equation number 2. I'm going to start with 2, then I went to 3. I start to write, but V equals V0, not squared, plus A times T. A is G here for in the y direction. In the y direction, the initial velocity is 0. Negative 9.8 times 0.45. It's negative 4.41 meters per second. Now, what does that mean, negative?
It's going down.
Yes. But here's, if you give me that answer, that's the wrong answer, by the way.
Jerk.
Why? This is the ball, right? Remember what I said about your velocity in the x direction?
It's always positive.
Well, not just positive, it's constant. It never changes. So right before the ball hits the ground, you have a velocity in the x direction of how big? In this case, is 20. Is whatever that initial velocity. That velocity in this direction always 20. It never changes. So right before it hits the ground, that number is 20 meters per second. I also get a velocity in this direction, in the y direction, of negative 4.41 Now you have x and y. Can you find r and theta?
Yeah.
So I know what the velocity now is. I got to use vectors again. This is one vector, 20 angle 0. This is another vector, 4.4 angle negative 90 degrees. It's coming down. That means negative. So what is my velocity is going to be? It's the square root of the x value squared plus the y value squared. Because they didn't tell you which direction. They say, what's the final velocity? So they don't want it in x, they don't want it in y, they want the final number. And I got 20.48. And what about the angle theta? It's the inverse tangent of the y value. The y is what? Negative 4.41 over the x value, which is 20. And that's negative 12.4 degrees. That's below the x-axis. So if I show you what that angle looks like, it's this one. That's your velocity. And this is the angle theta. So if that was sand, where the ball is going to land, is going to go in that direction. Or if that's a pool there, you dive into a pool, you're going to go in that direction, and that's the angle you're going to be entering the water with. So this example, your initial velocity was only in the x direction. There was nothing in the y direction. Well, a lot of times actually, you have initial velocity in both directions. So what we did is actually a zero launch angle. That angle, the table was not on incline. What happens if the table was on incline? Or, different example here. I don't know if you ever watched Evel Knievel when you were young there. Remember him? Or somebody, extreme, what is that? The bicycle, the crazy ones in sport, snowboarding. When they take off a ramp, they go in that direction. You'll see a skater comes down, or ice skater, or a guy on a bicycle, jet ski. They take off over speed. Will give you some initial velocity. I don't know. If it's on a motorcycle, 30 miles per hour. On an angle, let's pick an angle here of 22 degrees. What's going to happen? Let's assume the cliff, usually they come in like there's a little ramp there, they climb the ramp, and once they go up in the air, they travel in this direction. So this like a mount here, dirt, whatever, the rider comes on it, there's the motorcycle, bicycle, whatever you want to be, there's the person. It could be water skiing. You can have these boards in the water. You hit them on an angle, you go up in the air. Let's give you some initial height of this one. This was the initial height here, I don't know, it's 5 meters. And you go up in there. Now your angle, the launch angle here is not a zero anymore. It's not horizontal. There's an incline with it. So you're going to go up in the air, then you're going to come down. If you land right here, let's find again, what is that distance, x, traveled. T Same questions. The time the jumper was in the air. How long was he or she were in the air? And 3 is what? Final velocity before they hit the ground. These are the 3 questions. The velocity before he/she reaches the ground. Now what I need to know, this is the velocity, not in the x direction. Is this the velocity in the y direction or the x direction? I already told you, not in the x direction. So is it in the y direction? Nope. Neither. It's on an angle. So how do we find what the initial velocity in the x direction? What is the initial velocity in this direction? And what's the initial velocity in that direction? I'll give you a little hint. That was the first topic we did in chapter 3. We called it what? Components of a vector. How do you find the x component? Isn't that v0 cosine theta?
Yes.
And how do you find the y component? v0 sine theta. These are your initial velocity. So let me actually break the problem down into 2 parts, as like we did before. X component and y component. Initial velocity in the x direction is going to be 30 cosine of what? 22 degrees? Cosine 22, 27.8 meters per second. The initial velocity in the y direction, 30 sine of 22. 30 sine 22, what'd you get?
11.2.
11.2 meters per second. What else do we know in the x direction? We know our initial velocity in the x direction is constant, right? Constant velocity in the x direction. I'm going to write in x direction. I'm in the x direction. I just want to make sure you know I'm talking about the x direction. It's constant velocity. That means my acceleration in the x direction is 0. All these projectile, the acceleration in the x direction is 0. There's only one equation you can use in the x direction. That's this one. That's a subscript, v0 in the x direction. v0 in the x direction times t. So here x equals what? 27.8 times t. Again, one equation. If I know t, I know x. If I know x, I know t. In the y direction, what else do we know? Now, the question becomes, what do you want to use for reference? For the height. I can use the ground. I can use the launching point, that point. So which one you want to use for reference? Up to you. It will not change the way I'm going to do the problem.
The ground.
The ground? So if this is your reference, then you know your initial height. When the person took off that ramp there, what was their initial height?
0. No.
From here. What was it?
0.
5.
5, yeah.
When they landed, what was their final height?
That was 0.
That's a 0. I know the initial velocity. I know y. I know y0. What else do I know? I know acceleration, which is gravity. And that's negative 9.81 t. I mean, meters per second squared, not t. And that's it. Again, I have all these equations at my disposal. I just got to figure out which one will give me t. If I know t, I know x.
3.
3 again, because you're looking for t. Number 4 doesn't have t in it.
No, I meant 3.
Yep.
I said
So I really got to use this one.
just change everything to y.
Yep. Y equals y sub 0 plus v0t plus 1/2 gt squared. So equation number 3. The only bad thing about it, you got to solve a quadratic equation now. So if you know how to solve a quadratic equations, that's okay. This will be what? 1/2 times negative 9.8, that's 4.9 t squared. Some of you might have that on your calculator, solving a quadratic. You plug in the numbers, A, B, and C, and you have the answer. If you reshuffle this, you can say it's 4.9 t squared minus 11.2 t minus 5 is equal to 0. I don't like to start the square with negative. That bugs me. So I multiply everything by negative 1. That becomes a negative 5. That becomes a negative. That becomes a plus. Now, if you don't have a calculator that solves a quadratic equation, no big deal. Minus b plus or minus b squared minus 4ac over 2a. So if you can't remember that equation, I encourage you to get a tattoo with that one on it. I'm not a tattoo person, but you want to get that equation with the tattoo on it? Perfect. Now let's plug in the numbers.
So it'd be 1.
B is 11.2 with a negative, so minus a minus, that'll be 11.2 plus or minus negative 11.2 squared minus 4 times A, which is 4.9, times C, which is negative 5, 2 times A. Again, use your calculator, don't trust me with these. The square root of 11.2 squared so I got 11.2 plus or minus 14.95 roughly over 9.8. So one solution to that problem is, when you use the plus, the other one use the minus. 11.2 plus that number. One answer is 2.668 seconds. And the other one, 11.2 minus 14.95, hit divided by negative 0.38 second. Well, we know there's no such thing as negative time, right?
Yes.
So that answer is wrong. So that's the only answer that makes sense. 2.668 seconds. The only way that answer will make sense, be negative, if there's a hole in the ground and the person was driving through, he just didn't see it, but somebody else spotted. You go, okay, this is time, right here, t equals 0 right there. So the person was coming here about 0.4 seconds before he hits that point, but we just didn't see him. So that's the only way. But that's not the case. So that's my time. So that's question number 2. If I know the time, can I come back to this now, solve for x?
Yes.
So plug this one in. So that person's going to land really far, far away. Oh, you know what I forgot to do? Shoot. Shoot.
You forgot to change it from miles per hour.
Forgot miles per hour to meters per second. So a quick fix. This is meters per second. So you got to watch the whole video now to see that I made that mistake. I forgot to convert that. So I'm not going to go back and redo the problem. Oh, I forgot. This is meters per second. So that person was going, what? 30 times 2.24, roughly 67 miles per hour when they hit that ramp. You know, like almost 70 miles per hour. So that's why it's going to land way, it's not going to be right next to us. So what's the distance? I forgot about that stupid thing.
24.18.
That bugs me now. 74 meters, right?
Yeah. That was a long jump.
Yep. Again, can we get the velocity
So we
before the jumper hits the ground? We know in the x direction, there we go. Another picture here, the jumper again, just in case you forgot the story. The jumper leaves in this direction, but it has a velocity in the x direction. In the x direction, we say what? 27.8. This is the ground. So right before it hit the ground, the jumper has a velocity in that direction of 27.8. What is the velocity in the y direction?
maybe 74.
So again, we'll use that equation. V equals V0 in the y direction plus a times t. In the y direction, the velocity was what? 11.2. Acceleration negative 9.8. And t was at what? 668. What is an s? The one you saw there? That's an s for second.
Oh.
Yep.
Okay. I forgot that number
Yep.
for some reason.
So the velocity in the y direction is negative roughly 14.9. So now I know the jumper has a velocity in this direction. So what is the velocity then? I'm looking for that velocity. You're going to hit the ground with. It's going to be the square root of the value in the x direction squared plus the value in the y direction squared. .54 meters per second. Again, we changed the starting jump to 30 meters per second, not miles per hour. And what is theta? It's the inverse tangent of the y value, which is negative 14.9, over the x value, 27.8. Negative 28.2 degrees. So you're going to hit the ground at this angle theta, which is negative 28.2 degrees. God, they kick me out every 2 minutes.
Yeah, it's been doing that to me lately too.
Let's
It's
see.
weird.
I can try another problem. One more.
So that's the angle that he hits the ground with.
Correct.
I just can't have more sweet stuff right
Now, if you want the ball to travel the farthest distance possible, if they say, what's the farthest point? You really want to hit it at 45-degree angle. So when you see these golfers playing golf and they want to drive the ball far, they try to hit the ball when the ball leaves. They want it at 45-degree angle. That's what you want to get. That'll give you the farthest. Because if the angle's steep, what will happen? If the 45-degree angle, if you shoot at 45, let's say this is the 45. If the angle much steeper than 45, let's say 50, 55, 60 degrees, then it will go like this. This one, the angle is like 60.
Oh,
It doesn't go as far as 45. Or if you top the ball, you don't hit a 45, let's say a 25-degree angle. It goes like this. So for maximum distance, if you wanted to reach the maximum distance possible, you always want to hit the ball at 45-degree angle.
Does it land at the same angle?
Huh?
Does it land at the same angle?
It should land, yep. It's actually symmetric.
Okay.
If we neglect the wind resistant,
Great.
Valentina, everything should take, the time it takes to go from here to there should be the same time from here to there.
Great.
It's absolutely symmetric. Since you asked that question, let me rephrase some of the questions now. Tiger Woods, okay. Maybe I remember now to change the value from miles per hour to meters per second. When he hits the ball comes out of his club like staggering speed, 100 miles per hour, easily. So when Tiger hits that golf ball, that initial velocity so the ball leaves like this. Will go like this. The initial speed for it, let's say it's 100 miles per hour. And before I forget, let me convert that to meters per second, because I forgot to do it in the previous one. So 100 divided by 2.24, 44.64, right? Meters per second. 2.24, yeah. He didn't get a 45-degree angle, but he managed to hit the ball at 47-degree angle. So he hits it at 47-degree angle. How high does the ball rise? What's the maximum height? And let's add more to this. Let's make the course look like this. But on this end, there's like a little rise where the ball, he hits the ball right there. So Tiger hits the ball in this direction. And the ball goes up there, and it lands right here. So initial velocity hits the ball of 100 miles per hour, which is roughly 44.6 meters per second. He hit the ball at angle 47-degree angle. Let's assume the end of the where the ball landed there, that height is actually 5 meters above the ground. The question now, where's the maximum height? Is it right here? Somewhere from the picture is right there?
Yeah.
So what is the maximum height? That's what we're looking for. Find the maximum height. Find the distance traveled, that's x, we're looking for x. Distance x. Where did it land in relation to this point? What's that distance? Should we ask for the velocity before it hits the ground there? Again. Find the velocity before the ball reaches the ground. I said just before. Maybe the word just here. Right before it hits the ground. Just before the ball reaches the ground. Like right there. When the ball is right here. What's that velocity? About to touch the ground. Now we put a twist in the problem. The maximum height. Again, let's break it down to x and y component. Can we find, what do we know? Let's list what we know. We know the initial velocity in the x direction, which is what?
100 miles per hour, or 44.6 meters per second.
Almost. Try again. That 44.6 in that direction. It's not in this direction, it's not in that direction. Yes. 44.6 cosine of 47 degrees. And this is the initial velocity in the y direction, It's the y component.
So it's going to be sine of 27. It's 30.4.
Which one?
The cosine.
The cosine, yep. Initial velocity in the x direction is 30.4. And the initial velocity in the y direction,
32.6.
32.6. There's only one equation in the x direction we're going to use. X equals v0 in the x direction times t, 30.4 times t. Can't help you yet. I need t if I want to answer that question. In the y direction, what else do we know? You want to measure the height from where? From the top or the bottom, where it landed, or the ground?
The ground.
Well, let's be different. We always use the ground. Let me use this as reference,
Oh boy.
just to be different. It doesn't change my answer.
So would that be 0?
What's my initial height? Where was the ball in relation to that line? If you imagine that horizontal line, that's my reference.
Negative.
Yes, -5. What's my final height?
5?
From here,
0?
0. So really what you use for reference doesn't matter. We always use the ground. I could use that point. If I use this one, then the initial will be 0, the final will be 5.
Oh.
If I use that,
Just flip it.
the initial will be -5, and the final will be 0.
Just reminds me taking a reciprocal of it.
Super Bowl
Reciprocal.
or reciprocal? Except with the minus sign.
Yes.
Yeah. Now, what else do we know? The acceleration, which is gravity, and that's -9.8. Now, to reach the maximum height, why isn't the ball keeps rising? What's stopping it from rising, going higher? Well, the acceleration never changes, still -9.8. Velocity is what?
0.
Yes. The final velocity is 0. Right there. Final velocity in the y direction is 0. Otherwise, if the ball has any velocity there, it will keep on climbing. So that's what I know. That's all the facts about the problem. Now, if I want to find out how high does it go, that means I need to find what y is. There's my equation.
So why didn't we use the last one?
Well, if I use the last one, I know this, I know this, I know this. Well, what do you know? I can find out the change in height. So if I use the last equation, I'll go v squared equals v0 in the y direction squared plus 2 times g times y minus y sub 0. Now you got to be careful with this. I'm looking for the maximum height, not right here. I'm looking for that height, right? What is that height from here to there? So we're looking at that side of the story. I know the initial velocity or the final velocity. When you reach this point, what's your final velocity there? 0, so I got to use that. What's your initial velocity here? 32.6, positive, right? It was going up. Plus 2 times -9.8 times y minus y sub 0. Y sub 0 here is what?
-5?
If you want to use this as reference, negative 5. Yep, so it'll be a plus 5. .6 squared, 1062.76 minus, is that 19.6? Times y plus 5. What is 19.6 times 5 when you distribute that one?
Negative 98.
98, yep. Oh, I forgot the y here. So you bring this one here, 19.6y equals 1062.76 minus the 98. What is y equal to? .2 meters. We gave the ball really a ride there. That's about 150, more than 150 feet up in the air. That ball is up there. Almost 60 yards high. Well, that's taller than this building. Yep. If you use a pitch and wedge, that ball goes way up in the air. So the maximum height the ball will reach, it's not really 49.2. It's 49.2 from here.
I actually got 49.4.
Did you carry all the numbers?
Yeah.
Yeah. But that's 49.2 from here, right? Because I'm using this as reference. So from the ground, if I use this as reference, I got to add to it what? 5 more meters. So the maximum height from the ground, so it depends where you use for reference.
So if you plug in not 5 but negative 5, you would get...
Now if you use this as reference, the initial height was 0. You put a 0 there for this, and you end up with 54.2 or 4, whatever that number is. You know. Now, one more thing. We need to find the time it took. But I don't want the time it took to go from here to there. I need to know the time it took to go from here to here. Why? Because if I want to find x, I need to know the time. So how long it took the ball to go from here to there? Let's go back, revisit this information here. Is there an equation that will take us there? Could be the third equation. Let's see. Y equals y sub 0 plus v0t plus 1/2 at squared, right? Y is 0. Y sub 0 is negative 5. V0 is what, 32.6?
Yeah.
Minus 1/2 times 9.8, 4.9 t squared. Again, I don't like to begin with negative. I'll multiply by a minus 1. Nothing wrong with using negative numbers. I just don't like them. To start the equation with negative numbers, it bothers me as much as clowns. I don't know, something about clowns. They always freak me out, you know? You look at them like, what is this? Can I solve for t? Minus b, 32.6, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Let's see, what is the square root there? I got 31.06 or 31.1. So I'm going to have two solutions. 32.6 plus 31.06 divided by 9.8, 6.5 seconds, 496, or something went wrong here. 32.6 minus 31.06 divided by 9.8, and this is like 0.15 second, 16.
For the first one, I got 6.59, so wouldn't that be
6.59.
Yeah, wouldn't that be 6.6?
I got 6.49. 32.6
Oh, I
plus.
know what I did wrong. Never mind. I did 32.06. Yeah, that's right.
So 6.5 and 0.16. The 0.16 doesn't seem like logically possible for the ball to go from here to there. You blink your eye in less than that time. The ball doesn't go that fast. So that's the only logical one that makes sense. So now you go back to this equation to get x, and you go, where's the ball landed? 30.4 times 60.5. 197.6. That's nothing for Tiger meters. You'll see at 250, 250 yards, they hit the ball, you know. And one more question, what was the final velocity before the ball hits the ground? Again, same old story. We know in the x direction, this is the ground here. Here's the ball coming down. Has the velocity in the x direction, doesn't change, 30.4. Let's find the velocity in the y direction. What was that velocity? V equals V0 plus AT. The initial velocity in the y direction was in 32.6 plus the acceleration negative 9.8 times the time, which is what, 6.5?
So we're finding V0x.
Y. I'm trying to find the velocity in this direction. We know the
Okay.
we know the velocity in the x direction, that never changes. That's always the same.
We'll find velocity.
Sorry, I had them
Yeah.
confused. Sorry.
It's all right. If you knew the answer to it, you won't be here. Negative 31.1, is that what you got?
Yep.
So the velocity in the y direction was a negative 31.1. The velocity in the x direction was positive 30.4. That means the ball is going to be traveling this way. What is v and what's theta? V equals what? The square root of what?
This will get
30.4 squared plus 31.1 squared.
negative 31.1.
Yeah, when you square it becomes a plus, right?
Yeah.
So I cheat sometimes. I don't put the minus on my calculator because I know it's going to be a plus. 30.4 squared plus 31.1 squared, 43.5. And theta is the inverse tangent of the y value over the x value. Where's tangent here?
Negative 45.7.
Negative 45.7. Now, if the ball landed the same height, if it did, these numbers will be the same. This will be at 44.6, that angle will be at 47, if it was the same height. But the fact I played with the height, the number's a little bit off.